Okay, we're going to try something different. This is actually the problem that I couldn't do in class today. It's from lesson 3, number 33. I can't write with this yet, so I will need Gadget to do that. This is number 33. So what we have here is this figure, and it tells us that triangle APS, here's APS, is congruent to triangle UNS. That means all the parts are congruent, we know that. We also know that A is the, whoops, it shouldn't be A is the midpoint of DT. Yeah, A is the midpoint of DT. So we know that AD is equal to AT. And then I put that over here in given. I think I have a pointer thing on this. So I wrote that down, given there, and then we can say AT equals UN. That's because CP, AT is this one equals UN. If you would line your triangles up, flip it around, and match it, these two would match. Right here. Then we can say that A is the midpoint of DT, which is given, so we know that DA equals AT. So what we're trying to do is we have a parallelogram. We don't know that yet. But we're trying to prove that this is a parallelogram, and one way we can prove it is using the theorem that if two opposite sides are equal, and if they're parallel, then we know that the quadrilateral is a parallelogram. We don't have any way to show that this side is equal to this side, so we're going to have to go with that theorem. So we have dA equals UN, so we can say dA equals UN because UN equals AT equals AD, therefore AD equals UN. So that's transitive or substitution. So we have the sides equal. Now we need to figure out some way to get to show that they're parallel. So we can also say angle T is congruent to angle N. This is how far we got in class, and then I couldn't see how they could be parallel. But what we need to do is we need to extend. Let's see if I can get something to extend this with. We can extend the sides. Oops. I'm not exactly sure what I'm going to use here. We can extend the sides right here, down here. Extend those and extend these. And extend the transversal going down this way. I need to roll it on my mouse. And then maybe you can see then that we have parallel lines cut by transversal. These two lines are the parallel lines. Here's the transversal, and we know they are parallel because these are the alternate interior angles. Let me extend this a little bit more. These are alternate interior angles right here. So we know that DA, this whole line, is parallel to UN. So let me put the parallel sign in here. Because if two lines form an alternate interior angles with a form equal alternate interior angles with a transversal, the lines are parallel. So here's a transversal through two lines. The alternate interiors are equal, so we know that these two lines are parallel. And if the lines are parallel, then the segments within the lines are parallel. So finally, we can say DAUN is a parallelogram for two reasons. It's all in one theorem. AD equals UN. And the other one is UN and AD are parallel. So we have the two conditions. A quadrilateral is a parallelogram if the two opposite sides are equal and parallel. So I hope that helps clear that up. And I'm going to try to figure out how to stop this video and put it on YouTube. That's it.